these on the video. Anybody at home watching the video, I'm sorry. I just turned it on. We just did this. And that's it. I think that's really, and we did some homework stuff that you missed out on. I'm sorry. Come to class. Thank you. Is anybody missing? 2, 4, 6, 8, 10. Oh, yeah. One person missing. Oh, that's the one that told me. No. Including her. There's only one person missing. So the most common mistake is when people are trying to do this. They'll write, oh, that's a bad one, Jeff. They'll do this, and I've already made a mistake. Here's my, I'm very sorry. Like somebody looked at me like, well, that's what I just did, dude. Can anyone identify what mistake I just made? Or does it look good to everyone?
The minus x should be a plus.
Yeah. I didn't subtract g from f. I subtracted 3, which is a piece of g. I really need this to make sense. You guys told me I'm supposed to subtract g from f. Yes? Which part of this is g? That has to be subtracted from f. I really want this to make sense because this happens all the damn time in mathematics. Subtraction finds a way to screw us over. If I'm subtracting something, I have to subtract that whole thing. If you don't put it in parentheses, you aren't subtracting the whole thing, you're subtracting a piece of it. So you're not going to get the right answer. Okay. Now, for example, on a test or a quiz, if that's the only mistake you made, and then you had to do a bunch of stuff with it after that, I'm only going to take points off once. As long as you, does that make sense? Like if I went on and said, now find a g of 2 and find a g of 3, and your function's completely wrong because you didn't put the parentheses in, I'm only going to take points off once. If you did everything else right, because I grade on concept over repeated mistakes. Yes? Okay. Which is why I don't believe in Scantron. So what do I do now? Help me.
So now you add.
No, what's the very next thing I should do? Yes? Yes, you got it.
Plus, minus, plus. Oh wait, no, I don't know.
You factor.
What is this? What is this?
It's gonna be negative 3.
Ah, I see, that's what you, okay. I thought you were trying to say that, but I wasn't sure. Distribute the negative, so negative 3 plus x. And now we catch up to what Damien said. It's supposed to be plus x, not minus. Okay. And again, I mean, these are little mistakes. Easy to make mistakes. But you just gotta realize what's the main idea here. I gotta subtract g. G is more than one thing. I gotta subtract all of that. And then what's the last thing I could do, of course? Where's my like terms?
Plus 4x.
Yes. And now to do this is easy, yes? How do I figure this out? Just plug 2 in. 2 squared plus 4 times 2 minus 3. Yeah, you get 4 plus 8 is 12 minus 3.
Oh, 9.
No, you're good. Okay. Not too evil, but it's if you're kind of like forgot about functional notation, these kind of look like, you know, a different language. You have no idea what it's asking you to do. What it's asking you to do is not that bad. Oh, okay. This one is actually very simple to set up. Because what is this asking you to do? You divide these two, right? So what goes on top? X squared. What goes on the bottom? I like it. Now, does anyone remember how to get the domain of something like that? Domain is the collection of what? All possible inputs. All inputs that work. Is there a possible input that wouldn't work? Yeah. So what's the domain? Everything except for. And I would accept that in English. That's fine. You could just say all but 4. Or you could say x can't be 4. But to really be like mathematically precise, you would write all that crap down. So this means from negative infinity to infinity, skip forward. Yes? Okay. I kind of lean in the direction of, do you understand how to look at this instead of, do you know exactly how to write this? Concept is a little more important right now. But get used to writing the interval notation, because that's going to be big later. This thing, with my calculus class right now, I'm teaching Math 180 calculus. We just introduced this. This is directly in calculus. And I want to take a second and show you where this silly thing came from. And when I saw this, I thought Dairy Queen, but I'll be all right. Let me see if I can. This is nothing we have to worry about in this class, but since this is there, and we do this in pre-calc. We do this with the students in pre-calc. But I want to take a second and show you where this is from. Can you guys remember, if I give us 2 points, can you guys remember how to get the slope, Jeff? I give you 1 point, and I give you a second. There you go, friend. If I give you 2 points, how do you find the slope between those 2 points?
Just like rise over run. Like
Yeah. And the great thing is rise rhymes with the letter you want to use. Rise, wise. Run is the other one, which also rhymes. So on the top would be what minus what? The difference in what rhymes with rise? Y. So the difference in the y. So the top is what? Do you guys remember? M equals y2 minus y1 over x2 minus x1. Now, we will officially go over this later, but you all have seen this at some point. I know you have. Okay. Maybe it's been a while, right? Maybe you blocked it out permanent and you're like, torches it out. I want to know that. Okay. What if my points, go with me for a second. What if I had this funky graph here? Yes? That's obviously not a line. But do you agree with me that at every point it has a slope? If you're on a roller coaster, at every point you're facing somewhere, even though it's always changing. A line is just, I'm always facing this, right? Roller coaster, you're always got this changing line of sight. You know, oh God, right? Okay. Sorry. So if I had my 2 points like this, do you see why I might call this x plus h? Because can you tell me how far this is away? If that's x and that's x plus h, this is h away. For some reason, that's very important in calculus, and you'll get there. So what is this right here? Well, like if this is 7, how would I figure out what this is? How do I figure out the output? You can do it. If I know that the 7 is the input, how do I get the output? Take 7 and plug it into. Yeah, so this would be f of 7, this here, yes? So what's this?
F of x plus h.
Good, f of x plus h. And what's this? F of x. So what are my points? Now, are you guys all still with me? Okay, I'm doing a little bit extra that we don't really have to do now, but since this is here, I can't help but show it. So these are just 2 very freaky points. They're not 1, 3 and 1, 2. They are x, fx, and x plus h, f of x plus h. So here are the 2 points. What's the slope? Slope don't give a shit, they look weird. What does the slope do?
F of x plus h.
Yes, y2, the second y minus the first y, over
X plus h.
second h, so second 8x minus the first x, yes? So the difference in the outputs divided by the difference in the inputs, yes? And of course, what happens on the bottom? The x is canceled. And isn't that exactly what they have here? Okay, so I don't like when something gets thrown at you from nowhere that isn't all that difficult to see where it came from. So I want you to know where this is from. So what this guy does, let me kind of push my luck here. If I wanted a slope at this point, but I found a slope between these 2 lines, do you see how do you agree they wouldn't quite be the same? How do I make it better when I just make this point get closer? let me make I made a really very small slope. If I'm trying to get a slope like here, and I estimate it by moving over a little bit and getting the slope between those 2 points, that's not the same as the slope right there. Do you guys see? How do I make my estimate better? Get this closer, get this closer, get this closer, yes? In fact, how would it be the best if I could actually make h 0? But then how many points would I have? If I made h 0, how many points would I have? 1. Can I get the slope given only 1 point? No. Calculus finds a way to do that, where it's always 2 points. Okay, I think I've pushed my luck a little too much. I'm sorry. Just to give you a little preview. All calculus is at the beginning is take algebra and make slope apply to curvy dudes. That's the first part of calculus. There's a lot that goes into it. That's all it's trying to do. Okay. Which is why this function is such a big deal in the beginning of calculus, because that's just slope. So, can anyone identify the easiest part of this equation besides h? Because h is h. By the way, this goes back to your question from earlier, when you're like, well, so this h is not a function, because it's not h of x or something, it's just a number, it's just like an unknown number. Do we know what f of x is on example 12? Do we know what f of x is? Yes, they tell us, right? And do you see how that's part of what I need here? And like we just talked about earlier, if I'm going to plug it in, it'd be minus parentheses this thing. What I need help from you on is this. We did a problem like this. Yes? If I want to know what f of 3 is, what would you do? If I want to know what f of 3 is, what would you do?
Just plug 3.
Plug 3 in. Yes. So if I want to know what f of x plus h is, I'm going to plug in x plus h. Do it. I'll wait. So wherever you see an x, replace it with x plus h. Do it. Try it. Try it. Try it. Try it. Try it. If you don't want to try it, you can draw a duck, because from this distance, I won't tell the difference. But actually try it. If you're going to make a mistake, do it now, because I'm never going to look at this work. Give it a try. Tell me, somehow I got the answer is k. I'm like, okay. So this is f of x. I want to know f of x plus h. So again, wherever you see an x, replace it with an x plus h. So here, real quick, you guys are still looking at me like I'm crazy. What is f of, how do you spell Kindle again? Oh, for you.
E-O.
Huh?
E-O.
E-L. Damn it. Okay. So what's f of Kindle? Tell me. What's f of x? X squared minus 2x plus 3. So what's f of Kindle?
Kendall squared.
Kendall squared.
2 Kendall plus 3.
Okay, I like it. Right? What's f of pumpkin? Pumpkin. Squared. Let me put these in front, just be careful. Minus twice pumpkin. Plus 3. Okay, right? Functions are incredibly single-minded. The first step is easy as shit. Whatever is in here, I put it in place of x. What I get students do all the time, and some of you guys might have even thought this was the right thing to do, is they'll do this. Do you guys see that up there? Do you guys kind of see the logic? Like, okay, you put an h, so I'm going to put an h on it. But that doesn't follow what functions do. They're supposed to take something and plug it in place of x, yes? So this should be, good. That's correct. So I'm going to square x plus h. I'm going to double x plus h. That's the first step. First step, for evaluating functions that somewhere is just plainly and simply easy. I'm not saying that to make you feel bad if that doesn't make any sense. I'm trying to make you realize we didn't barely do anything. What did I do here? Didn't I replace x with x plus h? So what do I do over here? I replace x with x plus h. Right? Now what's the next thing I can do? Once I do that, I can step back and go, can I simplify anything? Is there anything we can simplify? And I got my Kindles and my pumpkins all over the place. Sorry. What can I do with this? Yes. So if I write it twice, let me give myself some more room here. Okay. Write it twice. And this one I could just distribute, is that cool?
Yeah.
And then if I distribute x squared plus xh plus another xh plus h squared. Woo! So I don't know if I need to point this out. I was lucky. So okay, let me back up. I took painting. Come to find out I'm not a bad painter. I've actually got some stuff in my office that I painted, but when I first took painting, I'm like, what the hell am I doing? So I'm like, did I tell you the story already? I told one of my class this story. And you're like, go ahead, old man, just tell us again. So I'm struggling painting, and next to me I had this kid that's been painting since they were like 4, right? Before they were born, their mom was painting on their belly, like, can you feel how to paint? And I'm like, I don't know what I'm doing. So I'm there like, and he's over there, done, here's a painting, okay, done, here's a A plus, okay. So, do you guys kind of with me? So I don't have inherent in me the ability to break things down into their shapes and kind of put it down. You with me? But then I realized I'll just do impressionistic, and then bam, everything opened up. All right, sorry. I was really lucky in terms of math. I naturally break things down. I don't even really think about it. I just naturally see the parts. And I think when I work with enough students over the years that I think a student thinks they're supposed to be able to look at the whole thing at once. That is insane. So that is my first step. I don't care what has to happen next. I don't care about it till I get there. My first step is shove that in. Then I step back and I go, oh, that thing, screw those, screw all you. This thing I can write twice and do it. Now screw you, you're done. This thing, screw you. I can distribute the negative. Do you see what I'm saying? So I don't know if this is resonating with anybody, but I always see students and it looks like they're trying to keep it all in their head. I'm like, holy shit. Break it down into each little part. Worry about the whole thing later. Yes? Okay. Now, with that in mind, am I done? What did we just figure out? F of x plus h, yes?
Yeah.
So how do I figure out Dairy Queen here? Or a difference quotient, sorry. It's supposed to be f of x plus h, and that's all this, yes? That is f of x plus h. You with me?
Yep.
Minus f of x, which is this here, yes? All over h. So that numerator's like just loaded down. Totally. Now let me just stop for a minute. If the amount of writing that just happened has you troubled, you will sometimes, like in pre-calc this happens even, which is where we are, you have to turn your paper sideways so you can get the whole problem on there. It's not going to happen a lot. It will happen every now and again. And the further you get in mathematics, I always wrote the least because I like to get to the point. But I had a lot of my friends in my classes that would write the homework was like this much paper. One problem would take 5 pages at least, and that was a nice, quick problem. You with me? So I always love it when a student's like, man, that took half the page, and I'm like, you don't know it. That is kind of a lot of work, but it really isn't, right? It's just copying shit down. Somebody pointed out, now I can do what? Can you see stuff that cancels? Yeah, x squared minus x squared. Gone. Negative 2x minus negative 2x. Gone. 3 minus 3, gone. Yes? Basically, can anyone tell me all the stuff that cancels? Can anyone tell me what's true about them? They all have something in common. Do it again?
They all got like terms, or they're the same power.
They're all from FX.
Wait, why are you canceling those out?
Because they do. And so
Yes,
here,
they do.
I'm sorry, because this is subtracting each of these, yes? So let me write this out. X squared plus 2xh
Oh,
plus
I
h
see.
squared minus 2x minus 2h plus 3. So you could distribute that minus,
I see.
and then you can, yeah, you're good. I was thinking about doing that, but I'm like, nah.
None of them have H.
Okay.
Yes, everything that canceled, none of them had h. Everything that's left has an h, correct? And what am I dividing by?
H.
Now, are you guys all cool with the fact that I can't just do this and say I'm done? Why? Why is that not fair?
Because that's principally H.
Because what's being divided by h? Everything. How did this guy escape? So he loses an h, he loses an h, that's it. Everybody gets divided by h, yes? So what's left alive? 2x minus 2, and that's it. Is there a plus h? Yes. There, John. Yes.
I thought you couldn't do that because, never mind. Just because in my head, I thought that you couldn't do that because they're not the same power.
Oh, let me do this. So what was left here before I canceled any h's was this here, right? Yes, because this died, this died, this died. Yes? Okay. Then I can write this. I can do one of two things, and I think I'll do this. Can't I take an h out? Then I just took an h out at the top. And that's why if you're dividing by something, it has to be divisible into each piece, or else you can't cancel it. Okay. In calculus, you'll do one more step with that. And it's related to a really big idea that I just started today in my calc class. But for us, that's all that matters, right? So for us, this is just an example of working with functions. In calculus, you're going to do a little more and see how that relates to finding the slope of a curvy line. Can you guys tell me real quick? Is there a single slope of this? A line has a single slope, yes? I don't care where you go on it, it's the same slope. This dude, what's happening to the slope? Every motion, what's happening to the slope? It's changing, constantly changing, yes? So if I find the slope of this, the slope is going to be a function. Because the slope at this value of x is different from the slope at this value of x, is different from the slope at this value of x. Again, this is something you have to worry about in calculus. So I'm sorry, I'll stop talking about it. But just to show you where some of this stuff is leading. Okay, go. Blah, 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 blah. Yeah, this is crap. Okay, I'm sorry. Profit is revenue minus cost. Revenue minus cost. You would subtract both of these things. So they just want to give a real life kind of example, yes? Okay. So, what I want to do before we go on, let me see if this is a good place to do this. Oh, this is a perfect place. Oh, kick ass. Okay. Because I talk too much. I don't know if you guys agree. I want you guys to work on something together. So let's see, 2, 4, 6, 8, 10, 11 course. 2, 4, 6, 8, 10, 11. Yeah, fine. Okay. Boom. Boom. Well, within reason. 2:30 a.m. You're like, I found where you live. Give me a sheet. Give me a worksheet, Jeff. So let's group up in. I don't know. Can you guys work together? Yes. So kind of meet in the middle or something. Can you guys work together? Right here. Yeah. Yes. And then you guys work together. And you three work together. So then you come up and you guys turn. And then you two work together. Okay. So these are all things we have discussed. All right, guys. I think most of you guys are almost done with this first side, if not done. Because I don't know if you noticed, there's another side. Like the light side and the dark side. I have a shirt that's got functions, and it spells LOVE, and it has the functions that make those shapes. So maybe I'll wear first of all. These four, hopefully, the minute you remember how to check, it's quick. Yes. What's the check? Vertical line test. If you could draw a vertical line and it goes through more than once, that means that input went to more than one output, and that's bad. Okay. So that's a no. What about this one? Yeah, I can't see any vertical lines that's going to go through more than once. That's a yes. What about this one?
Yes.
That's also a yes. Anybody know what this is the graph of? No. It's the graph of a shifted absolute value. Yeah. Absolute value has been shifted down by 3. But do you have to know that right now? No. But this is a function. What about, I'm sorry, it's a function. What about this one? No, it died. Okay, no. Okay. We did examples of these, but again, this is like relatively new to us. But if you just keep going back to the definition, domain is a collection of all the inputs that have outputs. Domain is a collection of all the x's that have y's. All the inputs that work. You just have to remember how to represent it. If I have a finite number of inputs and outputs, I represent it with set notation. What are my inputs?
1, 2, 3, 4, 5.
Good. It's the same as my password. It's crazy. No. And what are my outputs? Kick ass. Cool. If you had a repeat, you wouldn't put it twice, right? If I was like, who all's going to the game? Well, Jim's going, and Joe, and Jim's going, and Joe, and Jim's going. You know, so if there were repeated outputs, you only have to put them once. This one trips some of you guys up, and I don't blame you, but this is a very different way to represent a function. So this one we inherently know, if I plugged a 1 into the function, it would make it become a -3, yes? This one in your face says, if I feed a 1 to the function monster, it will spit out a 0, right? So I like somebody put next to this all the points, 1, 0, 2, 3, 3, 2, blah, 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 right? So then you made it look more like that problem, and then you could do the same thing. But here's a quick way to do it. What's your domain? This is my domain. And what's my range? This is my range. And then you're like, there, Jeff. And I'd be happy if you did that. Little tears would come down. What about this one? The difference between this one and this one is that this uses every single number between 2. Yes? That's when interval notation comes in. If I tried to list every number that has an output, that would take me the rest of my life, and the rest of my kids' lives, and the rest of their kids' lives, and the rest of their... Yes? Do you guys all understand that between any 2 numbers, there's an infinite number of numbers? That's kind of trippy. Like if you're thinking how to go from 0 to a billion takes forever, well, from 0 to 1 takes beyond that, if you count every number between. All right, I'll stop. So if I'm thinking domain, I go back to definitions. Domain is the collection of all the inputs that have outputs. So what axis am I focusing on if I have a graph for the domain? X, because that's where my inputs live, yes? So what's the lowest X value that actually has a domain, has an output? -4. That's the first time I see an output. And it's a closed circle, so I include it. And then everything has an output up until 1. That's the last one that has an output. Range, I do the exact same thing, except I look at the y-axis. The lowest output that happens is -5, and the highest output that happens, 4. And they're both closed circles, and this is like an understood closed circle because there's no open circle there, so I include both sides. So that's why I use a bracket, because it looks part of like a letter I for include. Please, dear God, if you write 4, -5, I will take a point off. Because you wouldn't say, who could be on the team? Anyone from like 18 to 11. You're like, Feel all right? Doesn't that feel a little off? Don't you need 11, 18? Okay. This guy, what do you have to be careful about? This one kind of stopped at the ends. This one tells you it keeps going. So domain, what's the lowest x that has an output? Yeah, negative infinity. Can I just go to infinity and be done with it? What do I have to throw out? Good, I'm good, I'm good, I'm good. Ah, shit. Yeah, so I gotta skip negative 3. So I always think of this as I skip negative 3, and then I go to, go to infinity. I like it. Become it. Okay. And then I do a very similar thing with the range. What's the only thing I have to throw out of the range? So if I look at it this way, I'm going to leave out negative 2. Become an infinity. Okay. How are we doing? This is better? Okay. All of this shows up in calculus in some degree. So you want to go into it feeling semi-comfortable with this so that when you do the calculus, this is a quick little thing. Some of these are getting a little trippy down here. But what's the domain of f? What's the only input I can't use?
X can equal -5.
Yeah, I can't let the bottom be 0, so I can't let x be -5. What about k of -4? What do I do there? Yeah, just plug a -4 in. -4 squared. Let me do this. So k of -4 equals 16 plus 1, which is 17. Now, real quick, I want to really make a big deal on this. This is k evaluated at -4 is 17. I cannot divide k, I can't divide -4 because these are not multiplied. This is one thing. This is what do I get when I evaluate k at -4? That's what this whole symbol means. It means that one thing. I can't break these up. Kick ass. So that's a thing. G of -3, not a big deal, but it does, you gotta remember how to do square roots, but this one's not too bad. What do you get? Yeah, you get square root of 1, which is 1. This is the first exceptionally freaky one. If I said f over g of x, you would have to do f of x over g of x. But I said f over g of 5, which is f of 5 over g of 5. So here's something I haven't done a lot of. It's called the construction approach. We sort of did it earlier when we figured out what f of x plus h is, and then we plugged it in. You construct what you need. What 2 things do I need? I need to divide 2 things. What are they? F of 5? G of 5. Let me construct f of 5. Let me construct g of 5, and then I'll divide it. And then you sort of avoid having this monster big x thing fraction staring at you. Okay. So what is f of 5? Yeah, 19 over 10. That looks great, Jeff. Thanks. And then g of 5? That's 5, yes? Or 5, that's how he said it. I just translated, like, I don't know what he said, but it was wrong. Oh, wait, this is Spanish. So then this would be 19 tenths divided by 5, which is 19 tenths times 1/5, which is 19 50s. Could I write it smaller? I could. I shouldn't. So, but does that make sense? This again is kind of related to what I said earlier. I break it into parts. The trick with doing this though is you got to make sure the parts you broke, you put them back in the right place. So I could do something similar here. This would be g of -2 minus k of -2. Do you see what I mean? So what's g of -2? Negative 6 plus 10 is 4, square root of 4 is 2. And then what's k of negative 2? Negative 2 squared is 4 plus 1 is 5. I like it. What's 2 minus 5? Negative 3. Cool. And then, of course, I had to give you one like this. Contractually obligated. So I just replaced x with what? E minus 3. And then what can I do inside here? Distribute. And then I get square root of 3b plus 1. Now the temptation is to feel like you're supposed to do more, so you force something weird to happen. That's it. That's all I can do. I don't know what the hell square root of 3b plus 1 is. And then finally we get this monster one here. Let me give myself some more room. How's everybody doing? You guys have got all that if you want? Yes. Okay. So this one, I'm going to do up here. 4 times, I'm going to replace x with negative 1 plus h. Now somebody asked a really good question. Jeff, man. Cancel, yeah? No.
It's attached to the 4.
It's a part of a subtraction addition. Division can't break into a subtraction or addition problem. Yes? Okay. Otherwise, real quick, can you reduce 19 thirteenths? Can you reduce that?
If we could see it, maybe.
Even if you could see it, can you reduce 19 over
No.
13? No. But isn't 19 12 plus 7? And isn't 13 12 plus 1? And then you should say right now, so what, Jeff? Right? Because division can't cancel parts of, I can't do this. 19 divided by 13 is not equal to 7. Yes? Okay, good. But of course, when I start throwing variables in, it just kind of, you lose sight of, these are just numbers. They have to act the same way. So what can I do? Distribute negative 4 plus 4h minus 1 over negative 1 plus h plus 5. So I get 4h minus 5 over h plus 4. And that's as much as you can do with it. Is that okay? Thank God, because that's enough. Okay. So let me announce this. I think, well, let's see. What is today? Wednesday? Not everybody's gotten in there. So let's shoot for our first quiz to be a week from today, next Wednesday. And it's going to be on factoring and 3132 out of the book. You guys with me? I'm going to say this for future Jeff. You said the quiz was factoring 3132. Because later I'm going to be like, did I say there was a quiz? Oh, it's me talking to me. Hey, all right. I used to call myself and say, Jeff, this is you from the past. Literally. All right. So if you have any questions, let me know. Otherwise, have a nice weekend. If you have a class tomorrow, hopefully that goes nicely. And I'll see you next Monday. The Monday after that is a holiday.